Okay then, we got our two leads. So our alligator clips soldered out. I'm just going to run some heat shrink up them. Just melt that off. Oh, that is the worst. Well, that one's not going to work. Should use the bigger stuff. That one will work. Okay then. You need two charged batteries. There's one, I'll just grab the other one. Plug the soldering on before we melt everything. Okay then. We've got these two charged 4 amp hour Milwaukee 18 volt cells. Check the voltage of each of them first. 20.17, 20.7. Okay. We need to get that terminal out. You can hook them out anyway. Okay, so positive there, negative there. That's where our two alligator clips will go, and we've just got to make a link wire between them. Too short. Okay, we'll measure across the outside of those two, and we should have 41 volts. Neg down there. Never fear, that was just a big capacitor charger. Hang on. Probe in there, probe in there. 40.5 volts. We're running on battery. Let's plug something into this and run these down a bit until let's get down to 36 volts, and then we'll plug the AC into this and do the reverse. Let's grab a soldering iron to plug into it, that'll be a good resistive load. Okay, so we've just got a 60 watt 240 volt soldering iron to plug in. And plug that in. We've got 40.3 before I plug it in. And we dip down to 39.6, but we are creating 60 watts. A neat little cooling fan in the back of the unit's going. Give this a few minutes. In a couple of minutes. Soldering iron's nice and warm and no issues, still holding 39 volts. Give it a bit longer. It's been about 15 minutes. Still got 37.9. Got a bit of a discrepancy between the two packs. I was just watching the outside of the two, so the full voltage. I decided I'd hook up these two little blue digitals. I knew they'd come in handy. That's what they're telling us. There's 18.6 in the left hand one and 19.2 in the right. I think we might plug the AC in. So I just need to borrow. Down the bottom. Still running on DC. 18.6 and 19.1. It's odd, it's not clicking over to AC. Maybe that's why it was thrown out, the AC side of it doesn't work. What a bugger. It appears as though the AC charging side of it doesn't work. So AC is plugged in now. Well, it looks like we need another way of charging it. The AC doesn't work, it won't sell for a charge. Well, here's what it is, I guess. We're going to have to set up a BMS and a bank of 18 volt cells separate to the UPS. I know we're going to get good power output out of it because it is quite a beefy model. Just for argument's sake, let's get a fan heater. Okie doke. This is a 2000 watt fan heater, but it's got a 1000 watt mode as well. We've got 38 volts in the batteries. It's just the fan, so that'll be about 50 watts at a guess. Wow. Big surge down. We only got 25 volts across the pack. And we'll stop that there. I can see wires smoking. Okay, so the UPS has got tons of grunt. I think it was the link wire between the two that just smoked. Batteries recovered nicely, 18.4 and 18.9. Just watch them two as I flick it again. That beeper was the overload beeper, overload warning beeper. No hot air coming out of the back of there. Alright, so with a decent battery bank that doesn't voltage dip like that, 1000 watts is plausible. Alrighty, thanks heaps for watching, guys. We're just going to have to build a battery bank and order a UPS and wait for that. And once we've got all that in place, we'll set it up and do a load test. It's a 1 kilowatt UPS, so let's see if we can get 1 kilowatt hour of batteries for the 1 kilowatt UPS. That'll be a good storage size. Thanks heaps for watching. I'll catch you next time.